goes on to the body. This whole thing is going to fit in there like this, like you see. But this is cut square, and this is cut square. And what causes us to get the right angle is these shims that we make. So I'm going to grab just a shim or two. So these are made with precision. So let's take a Stratocaster neck. Who's ever unscrewed one and stuck a business card under it and screwed it back on? Okay, you change the neck angle, right? This is the sophisticated version of that. Okay, that's what this is. These are made all at different angles. And the difference, this one is -8. The difference between this one and -6 or -10, they go in increments of 2. That means that if I went from -8 to a -6, I would have changed the neck angle by 1/2 of the thickness of a piece of copy paper. That's how minute it is. So we have these shims that go from 0 to +20 and 0 to -20. Then we have this shim here that fits on the neck. And we always make this shim a little bit of a pull type. We don't put it in square. We put a difference of 6/1000ths of an inch of pretension on it. So we set the neck angle with this one, like your fender and your business card, but we have super fine adjustability. And we have tools that we put on the guitar. We clip them onto here, they touch the bridge, and it tells you which one to start with. Okay, so we put that one on, we get the right angle. And whatever this one is, we put a difference of -6. So if this one was a +6, this one would be a 0. If this one was a 0, this one would be a -6. If this one was an 8, this would be a 2. If this was a 4, this would be a -2. So there's a difference of -6 between here and here. What that does is this sets the angle, and then this preloads the neck. It pulls the neck back a little bit, bends it back, puts tension in it, because that's exactly the same amount of tension that the string is going to put on it when it pulls up. So you see a lot less tailors with sort of this thing going on, because we have the ability to get the right neck angle. We have the solid wood coming through here, and then we can preload this to a very specific amount, and it preloads this, and the strings pull it up, and the neck is straight down to the end. And if one needs to change their neck angle in the future, it's just a matter of unbolting the neck. The service centers that we have around the world have these in stock. But let's say you're a do-it-yourselfer, you might be a luthier, one of your customers takes it to,
Whoever.
Acme Guitars, and he takes it off. Yeah, I've heard about this, I want to do it, and he calls, but he might not have shims in stock. But he knows he wants to tip the neck back a little bit or forward a little bit. He can call us, and with words, we can just say, well, what shims are in there? Well, one says 8 and the other one says 2, and you want that to be lower? How much lower? Just the tiniest bit. Okay, we'll just send you a 6 and a 0 and a 4 and a -2, and those are 2 steps, and put it in the mail. So you could talk about a neck angle over the phone, because they're all gauged. And by doing that, we end up with guitars that have a common thickness for the bridge and a common height for the saddle. So we don't adjust our saddles up and down. And so typically when someone builds a guitar, the way most guitars are built is they do the dovetail, they put the neck on, they glue it on, and they're done. They haven't got the bridge on yet. You can see our bridge is on now. And then they take basically a straight edge and they put it on, they take a jig that's a straight edge, it sits on the neck, and then on their workbench, they have 4 or 5 thicknesses of bridges. So it's how most guitars are made. And then they slide the bridge under there that's the right thickness for that gap. Put that bridge on. And then they string it up, put a saddle on, unstring it, adjust the saddle, work on it.